Hello, welcome to our session. This time, we will discuss Bernoulli differential equations. How to solve this type of equations. We have a problem: 6y squared dx minus x quantity 2x cubed plus y dy is equals to 0. We do not know what type of these equations, if it is linear in x or it is linear in y. So first we need to determine that the type of equations that. Okay, here is the solution. Okay, first thing to do is we need to test if this is linear in x or that is linear in y. Okay, that is 6y squared dx minus x quantity of 2x cubed plus y dy is equals to 0. So first, let's simplify this one, this x to the inside quantity. Okay, we have this one, 6y squared dx. Let's copy that. Minus this one, x times 2x cubed. That is 2x fourth. Plus this one, x times y is xy. Dy is equals to 0. And then after that, let's divide both sides by this 1 over 6y squared. No, that is 6y squared only. Okay, this can be cancelled out, and then the remaining is we have dx only. Okay, to continue, we have dx minus, we have here the 2x fourth plus xy dy, it's over 6y squared, s equals to 0. And then let's divide again with 1 over dy to cancel out. Okay, it's 1 over dy, cancel this one, then we have dy here. Okay, so to continue, we have dx over dy, that's minus 2x fourth plus xy all over, we have 6y squared, s equals to 0. Okay, and then after that, let's extract the fraction. So how to do it? It's just a simple algebra. That is dx over dy minus, okay, let's distribute this negative sign. That is negative 2x fourth over 6y squared minus, okay, let's simplify this negative. That will become xy over 6y squared is equals to 0. And then cancel out this one. It will become 3 here, the denominator, and then this one we have 1y here. After that, we have dx over dy, that's minus, we have x raised to 4th over, we have 3y squared, that's minus, that's x over 6y is equals to 0. Okay, so our form here is n dx over dy. So let's prove that if it is linear in x. Okay, so we have a formula that the Bernoulli is linear in x. It has a form of dx over dy. Okay, we have plus, we have p of y x s equals to, we have q of y, then x raised to n. Okay, so we have a formula, so we need to follow that in order to arrive that if it is linear in x. Okay, so we have here is dx over dy. Plus we have p of y, so we have this negative 1 over negative 1 over 6y. Okay, and then p of y, that's x s equals to, we have q of y, this one, that's negative, transpose to the right side, that will become positive, that is 1 over 3y squared, and then x raised to n. So we have here x raised to 4. Okay, so therefore the equations is this is in linear in x. Okay, so the Bernoulli equation is in linear in x. And then if the Bernoulli is in linear in x, we have again the formula, or we need to follow this format. Okay, so this one, this is the formula again. Okay, that is x, and then raised to, that's 1 minus n. Okay, and then we have the integrating factor of e, that's 1 minus n. Okay, and then we have p of y x, that's p of y only, p of y dy is equals to, we have integral of, that's 1 minus n, and then we have q of y okay, and then the integrating factor, we have a raised to, that's 1 minus n. Okay, p of y dy, and then this is dy. Okay, so this is the formula we need to use in order to arrive the general solution. Okay, so it's very long formula, but we have a pattern that this will be the integrating factor. Okay, or we can use this if. Okay, so we have integrating factor. Okay, so on for this one, the same integrating factor. Okay, so we need to analyze that what is p of x, p of y, and then q of y. Okay, from this equation, this is our p of y. Okay, this is our q of y, and this is our x raised to n. Okay, first thing to do is we need to solve first the integrating factor. Then the formula is integrating factor, or can we have this IF, that is E raised to, that's 1 minus n. We have P of y, and then dy. So let's solve this one. We have E, then integral of 1 minus n. So our in here is 4. Of our P of y, that is negative 1 over 6y. And then is dy. After that, we can get the difference of this one, that is E integral of, that's negative 3, and then that is negative 1 over 6y dy, or we have E raised to, that's negative 3 over 6, that is negative 2, and then this is negative, so this is positive 2. That is 1/2 integral of, that's 1 over y dy, and that is E integral of 1 over y, that is ln y, so that is 1/2 of ln y, or that is E raised to, that's ln of y, and then 1/2. But again, E ln is just equals to 1, so therefore our integrating factor will be, that's y 1/2. So let's use this integrating factor to substitute for the given formula. And then from here we have this formula, is x, this is the continuation, that's x, then 1 minus n, our in here is 4, so that is 1 minus 4, and then integrating factor here, that is y is to 1/2, then is equals to, it is integral of, that's 1 minus n, again our in here is 4, so 1 minus 4, our q of y, that is 1 over 3y squared, and then it's coming from this one, this value q of y, and then the integrating factor, again that is y 1/2, and then dy. So this is the continuation to solve the Bernoulli equation. And then after that, that is 1 minus 4, that's negative 3, raised to, that's y 1/2, equals to, again that is negative 3, so 1 minus 4, and then that's 1 over, or that is it's 1 over 3 y squared, again that is y 1/2, then that is dy. Cancel out this one, 3, and then this y square, and then 1/2, or we can derive that's 1 over y square times y is to 1/2, or we can have, that's y is to 1/2, that's times it's y negative 2. This denominator, let's move to the numerator. that will become, that's 1/2 minus 2. Then the answer is negative 3/2. So this is y is to negative 3/2. Okay, and then let's rewrite this one. This x negative 3, that is, we can down it to the denominator. That will become, that's y is to 1/2 over x cubed is equals to, that is negative integral of, that's y negative 3 over 2 dy. Then continue, we have y is to 1/2 over x cubed is equals to, it's negative, okay, that's y, okay, that's 3/2 plus 1, and then that is negative 3/2 plus 1, then the constant of integration, that is plus c. And then to continue, that is y is to 1/2 over x cubed, then negative 3/2 plus 1 by using the calculator, is negative 1/2. Okay, or this is negative y raised to negative 1/2 all over, that's negative 1/2 plus c. And then this negative can be cancelled out, negative y, so that y is to 1/2 over x cubed is equal to, okay, and then that is this negative exponent, if we go down to the denominator, that will become 1 over y squared. No, that is 1 over y, okay, and then 1/2, then get the reciprocal from the denominator, 2 over 1 plus c, or you can have y is to 1/2 over x cubed is equals to, that is 2 over y is to 1/2 and then plus c. After that, get the LCD of this variable. We have y raised to 1/2 over x cubed, that is 2 plus c, then times y 1/2 all over, that's y raised to 1/2. After that, cross multiply, then we have y 1/2 multiplied by y raised to 1/2, that's y is equals to, we have, okay, we have x cubed 2 plus we have c, then square root of y, okay, and then this is our final answer. Okay, so it's very long solution or long process, but the concept is you must need to familiarize the formula to solve Bernoulli differential equations. Then we have a quick review. Okay, from the top, this is the equation or the question. Then first thing to do is we need to identify if this is Bernoulli in x or Bernoulli in y. But this problem arrived expressed is in the form of Bernoulli in y or linear. no, that's Bernoulli in x. And we have a form of dx plus over dy plus p of yx is equals to g of yx raised to n. After that, we have this formula. Then isolate the integrating factor to shorten the solution. Okay. Then we arrive that our integrating factor is y raised to 1/2. After that, let's substitute to the formula. Okay, this is the integrating factor. After that, cancellation takes place. Simplifying, then adding the exponent, and then integrate. Then for that, we can arrive to our final answer. Okay, hope you understand our session. So keep on watching and subscribe for more updated lectures. Okay, thank you.